Happy Thursday, 6th grade. Today we're going to be drawing polygons on a coordinate plane. Our objectives today are that we can draw polygons on a coordinate plane and that we can find the area enclosed by a polygon by composing or decomposing using polygons with known area formulas. Just like yesterday's lesson, we're going to begin today by working on the independent practice problems together. Take a moment to either copy the coordinate plane on your paper or find some grid paper that you can plot our points on. Let's look at the first problem. We're instructed to plot 3 points, A, B, and C, and name the shape it creates. Then, we must determine the area of the polygon. By this point, we should be familiar with plotting points on the coordinate plane. If you need a review on how to do that, pause the video and look under the Helpful Links section on the lesson outline. Let's quickly plot these 3 points. Pause the video until you've plotted each point. Now we need to connect our points with line segments. We can see that this forms a triangle, and more specifically, a right triangle. The final step in solving this problem is to calculate the area of our right triangle. To do this, we must use our area formula of 1/2 base times height. We can find the length of the base and the height by counting squares on our coordinate plane, or by using the absolute values of the line endpoints like we did in yesterday's lesson. Let's use this strategy. To calculate the base, we must compare the x-coordinates of point A and point C. A has an x-coordinate of 3, while C has an x-coordinate of 8. Because these endpoints are in the same quadrant, we must subtract the absolute values of their x-coordinates. The absolute value of 8 minus the absolute value of 3 equals 5. Count the squares to check our work. Let's repeat this process to find the height of the triangle, the length of line AB. Here, we need to measure the distance between point A and point B. Their x-coordinates are the same, so we must subtract the absolute values of their y-coordinates. The absolute value of 7 minus the absolute value of 2 is equal to 5. Our height equals 5. Now that we've found the base and height of the triangle, go ahead and use our area formula to finish the problem. Pause the video here until you found the area of the triangle. Five times 5 gives us 25. Half of that is 12.5. This second problem gives us more coordinates to plot. Go ahead and plot these on the same coordinate plane we used before. You should be able to use this coordinate plane for all of the problems in today's lesson. Pause the video here until you've plotted all 3 points. It looks like we've plotted another triangle. Go ahead and connect these points. One thing I noticed right away about this triangle is that none of its sides run along straight lines. We haven't learned how to calculate lines on a grid that aren't straight vertical or horizontal yet. Fortunately, we can still solve this problem using our knowledge of area. I'm going to draw a rectangle around the outside of our triangle. What this does is create 3 smaller triangles around the outside that we should be able to find the area for. We can use the base and height of each of these smaller triangles to calculate their area. Once we've done that, we will subtract their areas from the rectangle around the outside. This will leave us with the area of our inner triangle. Go ahead and look at the triangle connecting points E and G. This triangle has a base of 1 unit and a height of 6. When we plug these values into our area formula, we find that the area of this triangle is 3 square units. Let's label this so we don't forget. Pause your video here while you find the area of the triangle connecting points F and G and the area of the triangle connecting points E and F. The next thing we need to do is find the area of the rectangle surrounding our triangle. This rectangle has a height of 6 and a base of 6. Using our area formula, area equals length times width, we find that this rectangle has an area of 36 square units. Now we can subtract the area of the outer triangles. Remember to follow the order of operations as we solve this problem. Subtracting the areas of the outer triangles leaves us with an answer of 16 5/10 square units as the area of our inner triangle. Continue using this strategy of composing and decomposing the polygons you plot to answer the final two questions on your independent practice sheet.